By the way, this is our first meeting, no, for the subject matrix analysis of structures or matrix structural analysis. So, nana ko'y post sa atong canvas kadtong I think tulo to kabok, no, including our textbook. So i-print lang to ninyo kadtong textbook ni Juan Sennett, Robert E. Sennett, no? Author. So let me first show our textbook, no? So muna yung atong textbook, Matrix Analysis of Structures by Robert E. Sennett. So basically all our lectures will be taken or based from this book. Okay, including all our assignments. So for this meeting, I'm going to discuss basically introduction about matrix structural analysis, no, matrix analysis of structures. So by the way, ba si Camille? Dire? Yes, Camille, palihog lang ko ugwan kanang arrange sa other groups nga
Game.
ilang time bitaw, no? So para lang sa natong lecture. Mm. Mm. Okay, I'm not available also on Monday and Wednesday, no? Friday na lang siguro. Friday, what time? What time on Friday? Yes. So karon, pila ka kuan ron, groups ang naa din eh. Okay, ang sa Wednesday group na siya or MWF, no? Group. Yeah. Monday is full man. Maybe pwede siguro about Wednesday afternoon. Dili mo available po? Anong wa naman giusa ang schedule karon unlike sa previous semester?
Ambot lang.
Yan. Pero nga to is purely online ra man ni karon, no? Purely online ra ni karon. Okay. So supposedly may datog usara ka kuan session para mausar og lecture kay balik-balik sa mong gyapon, di ba? Sige. Yan, let me know na ha. So hopefully by within the week, ma-iron out na nato. So by next week, kuha na ka ng ma-include na nato other kuhan. Kamo na tanan, no? Kamo na tanan nga group. Sige, sige. So that means pwede ba ni ma-record ni mo ang atong lecture karon? Sige, that's good. So you can share this to the kuan na lang other group, no? Sige, sige. Okay, noted. Okay, so let's go back to our main lecture, no? So again, this meeting, our presentation is just about the introduction about our subject, no, matrix analysis of structures or matrix structural analysis. I am again your lecturer for this subject. I'm Engineer Maratas. So I've been with the C department since 2004. So that means I'm serving the department of the University of San Carlos for 18 years now. But mostly as part-time, no? Part-time member of the faculty of the Civil Engineering Department. No? So, but I used to teach full-time also, I think from 2004 to 2009. That's for a good 5 years, no? Teaching full-time in the department. So I'm also a practicing structural engineer. I have my own firm. I established that in year 2008. So that's 14 years ago. Okay. And I have also my construction firm, no? So construction, yeah. So I established in 2013. So aside from being practicing structural engineer, so I also engage in construction management. Okay, so going back to our topic. So I think last semester, under man muna ko sa reinforced concrete design, right? Am I right?
Yes, sir.
So, yung matrix structural analysis, obviously, this is murag kuhan po ni siya kanang it's a type of structural analysis, no? So, and it's using matrices. Okay, so that's the only difference from the structural analysis that you have studied, no, before structural design subjects. So naman may mga theory of structures, di ba? So kanto siya structural analysis niya po siya, no? Mo ito'y classical or conventional analysis. So this is structural analysis. So this is integral part of any structural engineering project. And this is the process of predicting the performance of a given structure under a prescribed loading condition. And this involves the determination of the stresses, like the axial force, no, axial stress, shear, and bending, and also the process of finding the deflections and also the support reactions. No? So caused by the loads and other external effects. So kaning structural analysis, so mo ni ang process, no, of determining the stresses of your members, okay, caused by the external loads. Okay, so whether it's gravity loads like dead and live loads, or natural loads like due to wind and earthquake effects. Okay, so unsa man ang mga stresses nimo, no? So mo nang axial stress, shear stress, bending, okay? Yeah, you have also the deflections, no, or the deformations of your members, as well as the reactions, no, of the supports. So ang process na gitawag na siya og structural analysis, and obviously this is an integral part, no, of your engineering project, no. So dili man ka maka proceed sa imong design without the result of the structural analysis, no. So you need, of course, the stresses, no. So like for example, in our concrete, when you design a beam, you need the moment, di ba? So pagkuha sa moment mo na structural analysis, no. So whether imo na siyang beam by beam analysis lang or frame analysis using more sophisticated software, no? Okay, so ang proseso pagkuha sa imong mga stresses, the moment and shear, for example, for beams, itawag na siya og structural analysis. Okay? The structural analysis also, maka-predict po na, no, sa performance sa imong structure, no, kay based on a given loading condition. So makita nimo dito kung stable bang imong structure o dagko ba gayo gid siya og mga deflections, mga deformations, or mga drift, no, natural drifts like in the event of an earthquake, kung dagko ba gayo siya og sway. Okay, so you can do some improvements also. Okay, like maybe put some additional members or increase the sizes of the members to reduce, no, the possible stresses caused by the given external loads or the design loads. Yes. Unsa man eh? Dili siya makita kani karon. So dapat PPT gid siya. So taguan na.
Ay, pwede ra ma-share ang imong PDF, sir, pero i-set up siya og usab, sir.
Again, Camille, sa Camille?
Ay, dili si Camille, sir. Sorry, sir. Kanang
Yes.
okay ra, sir, nga dili siya PowerPoint. Okay ra nga PDF. Pero i-screen share siya og usab, sir. Kay sa Zoom, dahi nga window ata, sir.
Kani, okay na, dili. Dili siya, no? Okay, so akong i-window na ko daan dire. I-share na lang nako ang okay na. Sige, so going back, no, going on tag structural analysis, again, it is the process of finding the stresses, no, of your members caused by the applied loads, no, or what we call design loads, no, including the effect of your environmental loads like typhoons, wind, and earthquakes. Okay, and maingon kag mga stresses, there are several types of stresses, no, so axial stress, bending stress, no, shear stress. Okay, so in the case of a frame, so you have all these three types of stresses, no, so axial, shear, and moment, no. And also, when you structural analysis, it's also a process of finding the deflections, no, so or mga deformations among members as well as the support reactions. And structural analysis is really an integral part, no, in every structural engineering project, because you need the results of these stresses, no, before you can design the members. Okay, so if you recall, sa atong concrete, before to maka-design sa iyang concrete beam, you need of course the moment, di ba? You need of course the shear. Okay, so asa man nagikan ang shear og imong moment, so sa imo ning perform nga structural analysis. Sa structural analysis, maka-determine po ka if your structure is stable. Okay? So, maka more or less predict ka sa performance ng building, okay, how good it is when it is subjected to a particular earthquake event, for example. Okay? So, if dili ka siya maayo, dagko kayo siya sway, dagko kayo siya structural, yung lateral drifts, so you can make some adjustments, okay, to make it more stable or to make it more strong. Okay. Now, there are two categories, no, of structural analysis. No? I would say classifications. No? First one is the classical method. Mao na yung inyong agian, no, sa inyong theory of structures, no. So, pag mayong kag-determinate kuan lang siya structure, so you can easily analyze the member by simply using the equilibrium equations, no. So, for example, if you have a simply supported beam, so it's determinate. So meaning you can easily analyze it by simply using the equilibrium equations, no? So summation of forces, summation of moments, no? But if it is indeterminate, okay, so meaning the number of your known reactions is more than the available equilibrium equations, so it's an indeterminate number, so you can analyze that by using other methods, no? So like area moment method, no? And three moment equation and virtual work method, no? And many more. Okay? So kanto siya nga mga types analysis, classify to siya under the classical methods. Okay? Another one is matrix method, no? So sa maning matrix method, obviously, mo gamit na ka og mga matrices, okay, pag analyze sa imong member, no? Okay? But I would like to stress that both this matrix and classical methods are actually using the same fundamental principles. Okay? Now, for the matrix method, is the only in comparison to the classical method, no? So the big difference is that the fundamental relationship of equilibrium, compatibility, and member stiffness are now expressed in the form of matrix equations. Okay, so you'll be using matrices. So the purpose of this is so that the numerical computations can now be efficiently performed on a computer. Okay, so ang application ganing sa matrix is for computer programming, no? Okay, kaya if you use this manually, so after sa kag siyam-siyam, no? Kaya you will be dealing with matrices. Of course, these are, as you have so many unknowns, the matrices will become bigger and bigger, no? It will make you harder to perform this manually, no? So kaning matrix actually is really designed for computer programming. So actually sa atong mga assignments and even our exams, okay, so you will be using computer programs, no? So minimum is using Excel, no? Programming language. If you're familiar with other programming languages like MATCAD or even C++ or Visual Basic, then well and good, no? Okay, so minimum is Excel. Okay, so ang atong purpose kada dere is magbuhat ta og computer program using matrices. No? Actually kaning mga computer software na to gamit ni siya og matrix structural analysis. So ang method niya is matrix structural analysis. Alright. Now, most classical methods were developed to analyze particular types of structures. And since they were intended for hand calculations, so they often involve certain assumptions. Okay, and take note, these are unnecessary matrix methods. No? The purpose of having these assumptions is to reduce the amount of computational effort required for analysis. No? Matrix method were specifically developed for computer implementation. That's what I stressed, no, just a while ago, no. So the main purpose again of using this method is for application in computer programming. So they are more systematic, so they can easily be programmed. And general, the sense that in the sense that the same overall format of analytical procedure can be applied to the various type of frame structures. Okay, so basically ang imong kuan ra gyud ani sayon ra gyud kay niyang matrix, no, basta the only problem here is mag-anam na lang siya o kadako, but basically it's the same principle, no? Unlike in the classical method nga daghan kay kag mga different assumptions, so maglahi-lahi siya. Okay? Let us compare this so matrix methods can also be used to analyze frame, can be used only to analyze frame structures. So that's the limitation of the matrix. Okay, so can only be used for frame structures. Okay, but when you talk about finite element analysis, and by the way, this finite element method, okay, or finite element analysis, no, originates from the matrix analysis. And has now developed to the extent that it can be applied to structures and solids of practically any shape or form. Okay, so at least you have an idea about this finite element method or finite element analysis. In matrix methods, the member force displacement relationships are now based on exact solutions of the underlying differential equations. Okay. I hope you are also familiar with or you're done, no, with this advanced mathematics, no? Okay, so the mga differential equations na to. In finite element method, the member force displacement relationships are generally derived by the work energy principles from assumed displacement or stress functions. And finite element analysis, in comparison to matrix, no, generally yields approximate results, no? So approximate ang output, no, sa finite element method. No? Now let's continue. So flexibility and stiffness method, no? So kaning duha kuan siya kanang under gyapon sa matrix structural analysis, no? So naay duha ka method ang matrix analysis, no? So ang usa flexibility method, the other one is stiffness method. Ang ato actually i-discuss diri sa atong subject is the stiffness method. I'm going to differentiate, explain what's the difference between the two, as well as the advantages, no, and the disadvantages between these two methods. So when you say flexibility method, this is also termed as force or compatibility method. No? So that's another term of this flexibility method. No? Is essentially a generalization in matrix form of the classical method of consistent deformation. So, mura na gyapon isang classical method, no? Using the consistent deformation. Only that you have to transform this into matrix method. Matrix, when you will be dealing with matrices. No? So, in this approach, the primary unknowns are the forces, redundant forces, which are calculated first by solving the structure's compatibility equations. Okay? So once the redundant forces are known, then that's the time the displacements can be evaluated by applying the equations of equilibrium and the appropriate member force displacement relationship. So the flexibility method uses the force as the knowns. Okay? So sometimes this is also termed as the force method. Okay? On the other hand, this stiffness method, so which originated from the classical slope deflection method, is also called a displacement or equilibrium method. So another term of the stiffness method is the displacement method. Why? Because the primary unknowns are the displacements, no? Particularly the joint displacements, which are first determined by solving the structure's equations of equilibrium. So with the joint displacement known, the known forces are obtained through compatibility considerations and the member force displacement relationships. So basically, kaning stiffness method, this one originates from the slope deflection equation. Okay, so magka-remember mo, you have the slope deflection equations. So ang unknowns dito katong mga displacements, no? Or katong mga rotations niya, no? Okay, so i-convert lang to siya to matrices. So yeah, basically, kaning matrices po, this can be originates also from a series of linear equations. Okay. Now, the stiffness method is more systematic and this can be implemented more easily on computers. So therefore, this one is preferred for the analysis of large and highly redundant structures. Okay, so that's the basically distinct advantage, no, of the stiffness method over the flexibility method. So that is why most, if not all, of these computer programs are using the stiffness method of matrix analysis. Okay, so most of the commercially available software for structural analysis is based on the stiffness method. So why? Because it is more systematic, no, and this can be easily implemented using a computer program. Right. So let's proceed. Now remember, when we say matrix structural analysis, this is only applicable to frame structures. So frame structures. And so many frame structures. No? So frame structures are composed of straight members whose lengths are significantly larger than the cross-sectional dimensions. No? Okay, so na yung mga members. Ang members niya straight. So ang iyang length mas significantly larger, mas dako siya sa iyang cross-sectional area or dimension. No? Common frame structures can be classified into 6 basic categories. So there are 6 categories, no, of frame structures. And this is based on the arrangement of their members and the type of primary stresses that may develop in their members under major design loads. Okay? So there are 6, no? Unsa man ang 6? First, plain trusses. Plain trusses. Kanang truss, that's first classification of a frame structure. No? So when we say truss, so this is defined as an assemblage of straight members connected at their ends by flexible connections and subjected to loads and reactions only at the joints. Okay, the member of such an ideal truss develop only axial forces. So it's a two-force member, no? So you have only compression or tension if it's an ideal truss, no? So ang mga connections na niya, mga hinges or pins, no? So wala dili siya mo rotate, meaning wala siya afraid to rotate siya. Wala siya ay moment. Okay? So if all members of a truss as well as the applied loads lie in a single plane, well, the truss is classified as a plane truss. So kung saan lang siya ka-plane, so that's just a plane truss. Okay? 2D ba? What do you mean by plane trusses? That's 2D trusses. Two-dimensional trusses. You have only the X and the Y. Okay? Ano yung example nato sa plane truss? Okay, ang iyang mga joints assumed to be frictionless hinges. Okay, so it's free to rotate. So wala siya ay moment na ma-develop. So ang imong stresses nga ma-develop sa member sa imong trust, axial lang siya, no? So, si trust member, it's a two-force member, so it's either tension or compression. Axial lang siya, no? Second type of classification of a frame structure is a beam. Beam. When you say a beam, so this is defined as a long, straight structure that is loaded perpendicular to its longitudinal axis. No? So ang load niya is perpendicular to the longitudinal axis. No? Loads are usually applied in a plane of symmetry of the beam's cross-section, causing its member to be subjected only to bending moments and shear forces. No? So there are two stresses, no, that may develop in an ideal beam. Okay, so shear stress, and the other one is bending or flexural stress. No? Okay. But anyway, how about if ang nakoy load ingon na? Okay, there's another load here. Let's say P1, no? Okay, it is placed at a certain angle theta. So on summary siya, is it still a beam? Any answer? Nice. Are you still there?
But there is a
Huh? Again? Assuming I have this load. Okay. Placed at a certain angle, no? Theta. So, ang may tibuan ay karon, although this is just a single member, no? Okay? Pero dili na actually ni siya, as if we strictly apply this definition, kanin siya nga member will no longer be classified as a beam. Why? Because the load is no longer applied perpendicularly to the axis of the beam. Okay, dili na ni 90 degrees ba, no? So that means ang atong beam karon kani siya nga member naanay another type of stress. Unsa man nga stress na naman kay horizontal component ani, meaning na kay axial stress, right? So if there is axial stress, then dili na siya ma-classify as a beam because a beam by definition is just subjected to only two types of stresses. No? So that's bending and shear. Okay, so by all this definition, so the load is not applied perpendicularly, then that's no longer a beam. No? That is now a frame member. Okay, because a frame is subjected to three types of stresses. No? So axial, shear, and moment. Okay, so kung if we really strictly adhere to the definition of beam, right? But actually, in actual practice, magid na siya ay kuan kanang axial stress nga ma-develop nimo because you really analyze that as a frame member, no? Pero mo kasagaran tawag yung na if it's a horizontal member, it's a beam. Okay? If it's a vertical member, then that's a column. Okay, so another classification is a plane frame. Frame. So we have frame na nasa axial, na nasa moment, na napud siya shear. Okay? Ang imong joints karon sa frame, so rigid na siya, rigidly connected na siya. So meaning mo rotate na siya. I mean, is restricted ang iyang pag-rotate, no? So meaning mo develop na siya o moment. Okay? So muna ang example sa atong frame. Okay? So if it is just in one plane, so that's a plane frame. Or another term for this is 2D frame, two-dimensional frame. So, analyze ka of two-dimensional frame. Okay? When you say space trusses, o three-dimensional trusses po niya, no? Space. Another way of equivalent of this is three-dimensional trusses or 3D trusses. So, ang example, ano niya, kaning mga domes, transmission towers, and aerospace structures. No? Now, like plane trusses, the members of space trusses also develop axial forces. So, meaning, ang young joints are also assumed as frictionless hinges. No? Okay, so muna yung mga examples sa space trusses. No? So, kaning mga power, ano, transmission structures. Okay. Billboards, that's also a good example of a space truss. Another classification is what we call as grids. I believe most of you are not yet familiar with this term. No? Okay. So mayroong grid. So this is like a plane frame is composed of straight members connected together by rigid and flexible connections to form a plane framework. Members of grids may therefore be subjected to torsional moments in addition to bending and shear that cause members to bend out of plane of the structure. So basically, this is similar to a plane frame. The only difference here is pina-horizontal lang ang iyang plane. Okay? So yung unahin ni siya. No? So a good example of this is kaning floor frame na to, no? Okay? So, kanisang mga atop sa itong mga sports arenas, auditoriums, and aircraft hangars, this can also be classified as a grid. Okay? The floor framing system is also a good example of a grid. Okay? And the last one is kaning space frame or three-dimensional frames. So, mga gini ang ultimate, no? Okay, so pwede ra i-classify ni mo tanan yun as space frame tanan, no? So when you do analysis, okay, so well, nowadays you really have to use computer software. Okay, so you can practically design all structures as a space frame, no? Okay, or analyze any structure as a space frame. So space frame constitute the most general category of the frame structure. So this is the most general category. No? So members of space frames may be arranged in any arbitrary directions, may be connected by rigid or flexible connections. Nodes in any directions, no, may be applied on the members as well as even on the joints. So many examples at those space frames. So we analyze buildings, no? So we normally use space frame. So because it is the most general category of frame structure. So, yung space frame, ang member na niya, so subjected to shear moment, and also torsion. Okay? So, just like grids. Okay, so those are the 6 classifications of frame structures. Do you have any questions or clarifications? So again, a plane truck, plane frame, we have the space truss, space frame, and we have also the grids. So, maura na nga itong kuan. So, analysis sa trusses, analysis sa frame, 2D frames, no? Analysis sa space truss, analysis sa grids, analysis sa three-dimensional frames. So, muna nga itong studyhan, no? But using matrices. Okay? Now, do you have any questions or clarifications? So, ito yung mag-analyze ta. So, makuha ka itong ng yung mga displacements. If we really want to know the displacements, no, or the Excuse dali ah. Oh, sorry. So going back to our discussions, no? So again, ang objectives nato dere sa matrix structural analysis, no? So atong kwaon ang iyang mga stresses sa members, no? Or kwaon natong iyang mga displacements, mga reactions, no? Okay? Sa supports. Kaya una na lang niya gamit ta og matrices. Since kuan man ang objective gyud sa matrix is para for computer implementation. Okay? So ato na siyang i-program sa atong computer, no? So expect ta nga magbuhat tag programs, no? So at least using minimum is using Excel. Okay? Do you have any questions or clarifications? So siguro ari
None
lang
so far, sir.
Ha?
None so far.
Okay, so ari lang sa siguro takutob sin so wala pa man ang other kuan good group. So para makaapas pasad sila, no? Okay, so ari lang sa atas sa introduction. So there is a question, Visual Basic ang gamiton sa Excel? No. Kuan man ni siya. I'm actually referring to the different computer programming languages, no? So Excel is the or less let's say minimum, di ba? Requirement na to, no? If you're familiar with Visual Basic, so you can use Visual Basic also in your computer programming. If you're familiar with C++ or if you're familiar with other computer programming languages, no? MATCAD is quite easy also, no? So you can use MATCAD if you're familiar with it, no? Okay, instead of Excel, no? But most of us are very familiar with Excel, so Excel would be fine, no? In your program. I will be showing you also some of my programs in Excel. Okay, so para at least you have more or less an idea, no? Okay. So for example, analysis of trusses, so nakatay buhat na programa ni, no? So pakituon sad mo na ko ana, then at least na mo idea pag buhat sa dyan yung pagaling ng program. Now, I want you to kanang develop your own program, ha? Okay. Before, I usually require my kanang part of the oral examination ba, no? So makita nila ang ilang program, no? So at least kay bawo sila, no? Kung matana ko, di sa manigikan, di sa mani, something like that. So maybe our final requirement would be like that also. So I'm going to ask you some questions, no, regarding your program. Any other questions? Guys? No questions?
None, sir.
None, sir.
Okay, so I think that ends our meeting, no? For today. So Camille, I'm going to wait for your feedback regarding our schedule, so I can announce it for para next week mausa na tatanan, no? Ang atong discussions with other groups. Okay, so that's all, and have a pleasant evening to all of us. So see you again. Hope to see you all again next week for our next lecture. Thank you, everyone.
Thank you, sir.
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 Sir.
Thank you, sir.
Thank you so much,
Thank
sir.
you.
Thank you, sir.